Hello everyone, I hope we've been so good with our lives. Today I'm going to take the lecture video on polynomials, still on algebra. This is our sixth lecture video. We have 4 more topics to treat. So I begin with the sub outlines, which is right from the introduction through to some problems which involves polynomials. Okay, this will be our sub outline. I'm hoping this will be a full lecture video instead of having multiples of it, so you flow with me. Let's begin with the introduction of polynomials. If you look at my slide 2, it says a polynomial is an algebraic expression of finite sum of terms. The key word is some finite terms. Now you know what finite means. When we did the set theory, you know what sum means. It means you are adding up certain things. You know what terms mean. So we are summing up some finite terms, and that expression can be given as equation 1. So these terms are in this form. It is finite because I have the last term here as a0. It is finite, assuming I had it as axn plus certain things ax, and I have 1 2 3 dots here. This is not finite, and this doesn't make it a polynomial. You take note of that. Okay, they are finite sums of terms. Now there are some conditions we must go through. The first condition is that, look at condition 1, my n must be a positive integer. We've gone through this, and this n is an index, so we've done indices. Indices or index are positive integers. It means we expect whole numbers, 1 2 3 0 and all those things, not negative numbers, not fractions. Now the a here are also real numbers. Real numbers is the entire real line, so from negative infinity to positive infinity. This means a can take negative values, unlike n. A can take decimal 0.2, unlike n, and so on and so forth, because it's a real line. But a cannot be 0. Why? Because a is a coefficient. If a is 0 here, all the terms will go to 0. A is multiplying them, and hence we don't expect a to be 0. Then the last thing is our x, which is a variable. Now take note, this is just x. It means it can be y, it can be z, it can be b, it can be a. They are the variables here. If I use a, it means that my coefficient term must change from a to something else. You take note of this too for me. Okay, having said that, let's take some examples of polynomials when these conditions are met. So from slide 2, everything there is a polynomial because the terms are finite. They are equated to certain things, to zeros. But my interesting thing here will be on slide 3. Is this a polynomial? Yes, it's a polynomial. Why? The terms are finite. There are 3 terms here. My n, the indexes are 2 1 0. Trust me. Here is to a power 1. Here it's as if we have x to a power 0, which we don't write. So it means n is a positive integer. It is met. My coefficients are 3, so a1, a2, a3, they are not equal to 0. My second example, yes, it is a polynomial because it has 2 terms. It has 2 terms. It is finite. The n is also equal to 2. It's a positive integer. My third example, yes, it is a polynomial. These dots are in the middle, and the last term is 24, and the indexes are positive index. The leading coefficients are 4 5 negative 8 and 24. So there's a polynomial. If I come to example 4, this is not a polynomial. Why? Even though my leading coefficient a1 is 10, a2 is 6, it is satisfied. But look at the index of my x, it is -1. This is not a positive integer, it is a negative integer. But then the second term is a positive integer. Because of this term here, it refuses to be a polynomial. Okay, now this next example is also not a polynomial. Why? Because I have some square roots this term here. If I want to do away with the square root, you realize that you will have x to the power half, and this is not a positive integer, it is a fraction. Okay, now the last example is also not a polynomial. Why? Because now I have x as a divisor. If I take it up, I'm going to get 3x to the power -1, the reciprocal, plus 5, and this becomes an issue. The negative becomes an issue. And hence, if you look at the remarks I have on slide 3, it says we don't expect negative or fraction of the index, which we've seen an example. We don't expect a variable as a denominator, which we've seen an example. And then we don't expect a radical sign of the variable. These 3 examples I have gone through with you just in this last 3. So these are not polynomials, you must take note of them. Okay, now there's a way to classify polynomials. If you're able to identify them, you must be able to classify them, and that is my slide 4. With the classification, there are 2 groups. We can classify them by degree or by terms, or someone will say type. They are the same thing. If I want to classify by degree, it means I'm looking at the highest degree, the highest degree. If I want to classify by type, I'm looking at the number of terms I have in the polynomial. These are 2 different things. So look at the table here. If the highest index is 0, it means you have just a. It's as if you have x to the power 0. The highest index is 0. It is a constant polynomial. If I have ax, it's as if I have to the power 1. It is linear. Quadratic means I have 8x to the power 2. The highest order is 2. So index 2. Index 3 means it is cubic. Index 4, quartic. Index 5, quintic. Then the question is, what happens when it's greater than 5? What name do we give to that? Please, you check that for me. So look at the table in slide 4. The examples are given. Why it is quintic? Because the highest index is 5. Why is it quadratic? Because the highest index is 2. Why is it cubic? Because the highest index is 3. You know what index are? The exponent. Okay. But if I want to classify by terms or type, we are looking at the number of terms. So 1 term, it is mono. This is an English word. 2 terms, it is bi. 3, tri. And we add the polynomials. So monomial, binomial, trinomial. When you hear these terms, you know you are dealing with 3 terms, 2 terms, or 1 term. And anything greater than 3, we call it polynomial. I've given the answer, but you have something to check out here for me. Okay, so look at the table 5. Why is it trinomial? Because it has 3 terms. It is well defined. Why is it binomial? Because it has 2 terms. Why is it monomial? Because it has 1 term. Okay, so let's quickly take example smart guess on slide 6. I'm saying that my first term is linear. Oh, sorry. My first term is linear. Why? Because the highest index is 1. This I still have x to the power 1, which we don't write. Why is it a monomial? The number of terms is also 1. It's just one term. Why is the degree of this polynomial quadratic? The highest index is 2. This is what I have here. This is to the power 1, but the highest is 2. Why is it binomial? Because the number of terms are 2. So term 1, term 2. Then the next example is also quadratic. Why? Because the highest index is 2. This one here. The index here is 1. The index here is 0. But you know we don't write to the power 0. Any number to the power 0 is 1. And why is it trinomial? Because the number of term is 3. So term 1, term 2, term 3. And that is how you easily identify these things. If it was confusing, you just repeat the video or the words I said here, and then you will get it. Okay. Now that takes us to the last but one thing to talk about, that is operations. In mathematics, there are simple operations. We add, we subtract, we multiply, we divide, we evaluate. Evaluation means that you set the value to something and then you substitute into the function. That is the evaluation, and that is basically what we'll be looking at throughout these polynomials. Don't forget, you can add more than 2 terms. More than 2 terms. It can be 3, it can be 4, it can be 5, and you can still look at these operations. Now there are some properties we want to go through when we perform these operations. The properties are such that whether I add 2 polynomials, I subtract them, or I multiply them, or I divide them, the result will still be a polynomial, irrespective of what I do. But when it comes to finding the degrees of polynomial, when I add 2 polynomials, the degree of this will be either the degree of the first one or the degree of the second one. In the same way, if I find the degree by subtracting 2 polynomials, it's the same thing. It will fall under any of the polynomials. But when I multiply 2 polynomials, it is a different story. The degree of the resulting polynomial will be the addition of the 2 degrees. I don't know if this sounds very well, but it's simple as that. When I multiply these 2, the resulting degree will be the degree of this guy plus the degree of this. Okay, and then the last property is that we can factorize polynomials into lower degrees. So polynomial 1, if I have a polynomial 1, I can factorize them into 2 different forms, but they will be of lower degrees. Okay, we'll take the examples and then we'll get to appreciate these things, so don't worry. Now let's take examples. I want to add or subtract polynomials. In adding or subtracting, there's one interesting thing we want to take note of, that is like terms. We've had group like terms when we're solving our things like Euler series. Group the like terms. So like terms are those of the same unit or the same index. So I have polynomial 1, polynomial 2. Why is this a polynomial? The terms are finite. The indexes are positive indexes. The coefficients are not 0. There are 3 things we always want to look at for. Our n must be positive integer. Our a must not be 0, but it can be anything. And then our x must be a variable. Or let me say I need a finite sum. The terms must be finite. Let me write it well. So I need finite terms. Don't forget these keywords. Because we are looking at like terms, this guy takes this. I'm adding. This one takes the second one, and I get this. And then the last one will take the 10. Because they are constants. The degree is 0. They are constant. This is how you group like terms. So those with the square index, when I add this, I'm going to get 7x squared. Those with just one index, I'm going to get x, and then those with no index, that is a constant, I'll get -5. Then you can confirm the properties. When I add them, degree of P1 was 2, degree of P2 was also 2. When I added them, what happened? The degree of P1 plus P2 is also 2. So it is either less or equal to any of them. In this case, it was equal to, okay, any of them. The second example, when I want to subtract, you can try the one on the slide, but I want to take a different thing. When I want to subtract, I'm grouping like terms. This guy has no term to correspond with, but this 5 can take the second term only, and nothing more, nothing else. It means that my 4x takes 0, my 7 will take 0, but my 5 will take the 9, because that is the like terms. So I have -4x squared, I think, plus 4x minus 7. If there are no other terms to compare with, it is 0. So that is what I have done. Okay, so let's look at the property. The degree of the first polynomial was 1, that is the 5x. The degree of the second polynomial was 2. When I subtracted them, degree of P1 minus P2, I had 2. The degree will be 2 from here. It is 2 because of this term. What do you tell? You realize that this is one of this, that is the degree of the second one. So it says it will be less or equal to any one of it. Alright, now we move on to the multiplication. If I want to multiply polynomials, I multiply them term by term. In this case, there's nothing like terms. We don't deal with like terms here, so no like terms, but rather it is term by term. So 5 will take x, this same 5 will take 2, and you know this will result to 5x plus 5 times 2, and this is what I get. You must be smart about this. Now let's look at the properties. The degree of 5 is 0, the degree of this is 1. Now you know what degree means, so I will not explain why it is 1. The degree of the resulting value is also 1. What does the property say? The property says that the degree when you multiply the degree of polynomial 1 times polynomial 2 is when you've added the degree of 1 plus degree of 2. 0 plus 1 is equal to 1, and that is what we have confirmed. If I take example 2, 5x will take 3x, 5x takes 3x, this same 5x will multiply 6, and I'm going to get this value. You can confirm. Property, degree of 5x is 1, degree of this is also 1, and so I expect that when I multiply them, the degree will be 2. Is the degree 2? Yes, that is here. So this have been confirmed. The properties as simple as that. There's another property, another operation is a division. This is a simple division. If you look at my slide 10, there's a common divisor. I can separate terms and then I do some cancellations, so I wouldn't waste much time on the division. Okay, it also takes term by term. Alright, now the interesting thing, as we all know, is the application of what we learn. So I have my first problem here. it talks about a company, a pharmaceutical company dealing with drugs, and then they want to check the effectiveness of two drugs they've produced, how effective these drugs would be in our system with respect to time. That is a preamble. And so it gave the effectiveness of drug A as equation 1. It gave the effectiveness of drug B as equation 2. So some terms have been defined. This, you realize that it is not set. It is not logarithm. It can be indices, because I see indexes there. But I'm adding certain terms, and so what should click is that you are looking at a polynomial. It will not be stated that add this polynomial or do this, but you must know that per the expression here, it is not a trig function. It is not set, but it is a polynomial. Equation 2 is also a polynomial. So right away, you know you are dealing with polynomials. Okay. Question 1 says, what is the total effectiveness of the two drugs combined? Combined means we are adding, as expressed in equation 3. Adding, we are going to use like terms, so you should know what the answer would be here. I know it's going to be something t squared plus something t plus something. You must find this. Okay. The second question says, if the drugs interact let me take my time to pronounce this word, multiplicatively in the bloodstream, find the expression that represents this. Multiplicative means you are multiplying. So we are multiplying EA and then EB. When I multiply this, I know I'm going to have something to the power 4, something to the power 3. I know very well, and so on and so forth to the last constant. We are multiplying two polynomials, which we've done on operations, and so this is how we apply polynomial operations. So you find the answers in question 3. It says, in each of the cases, what is the effective rate at time 2 hours? And so this brings us to the third operation, evaluation. It means you want to solve the problem at t equal to 2, at t equal to 2. And it's going to be something milligrams per liter, something milligrams per. You must find this box. This is to say that if your answer for question 1 and then question 2 is wrong, automatically your answer for question 3 would also be wrong. That is a must, because you're going to substitute wherever you see t as 2 in the answer. I hope this is clear. So take your time and solve this problem, and then apply the operations of polynomials. Okay. Now, what is the last thing to talk about in this lecture video is a long division. This is different from, permit me to move up here in slide 10. This division is different. You realize that the denominator is a monomial. The term is just 1. In slide 12, in the case where the denominator or the divisor, that's the name we call it, is a binomial. Now we know what a binomial means, 2 terms. Then you can look at it in a simple division form. This brings us to the long division approach because it's a binomial divisor. If you want to solve it, you've come across there's 2 something 3. This is how we write it. Now whatever is under the square root is the divisor, sorry, is the quotient. I hope I'm not mixing things up. Is a dividend, that is the numerator. What is above it is the quotient. It means what you got. What is left is the remainder. and then you know this guy already as the divisor or the denominator. There's a rule that if I'm dividing or find a long division, I'll end up with the quotient multiplying the divisor plus the remainder. Please, when you finish with the long division, always test this answer. Test this using this equation 3. I already have equation 3 up, so let me see equation 4. Always test and see if you're going to get what you had. If you don't get it, it means there's something wrong with your long division. So let's take 2 examples, and that'll be it for this lecture. The first example, I'm dividing, this is the question: divide the numerator by 2x plus 5. Because it's a binomial and the divisor, I have to use the long division approach. And how do we use a long division? There are things we must consider. As you can see in slide 13, we divide, we multiply, we subtract. So I first write my long division symbol. How do I start with the division? The first term by the first term in the dividend, and that's what I have here. So 6x squared divided by 2x, I'm going to get 3x. I write it up here, and then now I multiply it, this term by 3x, 5 by 3x. So I get 6x squared plus 3 times 5 is 15, and then I subtract. In subtraction, this goes to 0. 7 minus 15, I get negative 8, and I drop the last term here, so this 15x. So when I drop the last term, I get negative 20. I bring negative 20, so I can do away with the 0. Now when I'm done, I go back to this same guy 2x and divide by the next term, this, and that's what I have on the other side of it. I'm going to get 8 divided by 2 is 4, yeah, negative 4. So I write it up here, negative 4, and again these 2 multiply the negative 4, and then this 5, I don't know why to draw the arrow, but let's see, this 5 also multiply the negative 4. I hope my green pen is not messing things up. So let's see, 2 multiply negative 4, I'm going to get negative 8x, and then the 5 multiplying the 4, I'm going to get negative 20, and then I subtract. You always divide first, you multiply, and then you subtract. Please don't forget this. When I subtract this, I'm going to get 0, 0. It means that my quotient is 3x minus 4, my remainder is 0, and my divisor, you can never get a divisor wrong. It is always given in the problem. So it says that whatever was given is equal to the x times the quotient plus remainder. Can you check that if this is correct or wrong? Can you check it? Let me get, so this guy here, numerator should be this. You can verify. This brings us back to multiplication of polynomials. So 2x plus 5 times 3x minus 4. Multiplication of polynomials. This takes that, this takes that. I think I'm going to get 6x squared minus 8x, and then the 5 takes the 3x, 5 takes 4. That'll be plus 15x minus 20. and that gives me 6x squared. 8 plus 15, that will be my plus 7x minus 20. It is the same thing as my numerator, hence my answers are correct. So this is correct, this is correct. This is how you test for it. Okay, always ensure you test for them, please, just to be on the safer side. Okay, so this brings me to my last session on the test here. I've already solved everything, but let me clean it and then help you out. Let me just be fair enough. Oh, okay. We are given a polynomial of this form, x cubed plus 6x squared minus blah blah blah, and we are asked to divide by x plus 7. So what do you do first? This guy will have to divide the first term. So x cubed over x, I'm going to get x squared. So I write x squared here, and then I multiply. When I multiply again, x cubed plus 7x squared. You subtract. Don't forget, you always have to subtract. So I get 0. When I subtract this, I'll get negative x squared. When you are done, you bring the other terms. Minus 9x minus 14. Okay, then what do? The same first one will divide this one now. So it means my next term will be negative x squared divided by x. That's going to give me x, negative x. So I have minus x here. I multiply and then I subtract. So let me use red now. Oh, I can erase this and say that now x will multiply this, and then 7 will multiply the same guy, giving me x squared minus 7x, and then I subtract. So I get 0, negative 9 plus 7, I'll get negative 2x, and then I drop this last term here, minus 14, because it hasn't been used yet. So my next step is that I'll have this negative 2x dividing the first term x. Now my concentration is here on then the first term, which gives me negative 2. So I bring negative 2 here. I can clean this one. So now this x will multiply these two, and then this 7 also multiply these two, and that's going to give me negative 2x minus 14, and I subtract. Everything goes to 0. So it means that my quotient is this equal to what I had on the upper. It is x squared minus x minus 2. X squared minus x minus 2. My remainder is 0. And you want to prove that this upper or your numerator is equal to this guy. When you prove it or you test, you realize that indeed it's equal. This is equal to that. And this is how you do the long division. Now the next question says divide by x plus 3 and then find the remainder. I hope you can be able to do that. Just try your hands on and see what you get as a remainder. Okay, I don't have an answer to that. That is just unfortunate. And then the last thing is a problem of the day, which says that you are given a volume of a rectangular solid as a polynomial representation. The length is given, the width is given, and you ask to find the height of the solid. Now the solid is a rectangular solid. It means it has 3 sides. because I'm using volume. It is not just a plain rectangle that say that area is length times breadth. Here it is a volume. It means I have three things to consider. The volume is given by equation 1. The length times breadth or the height times the width. Now some terms are given. V is given, that is a volume. My length is given as the length. My width is also given. And so by simple change of subject, I have the height as this. And this results to what I have here. You realize that in the denominator, I'm performing multiplication of polynomials. And so I take it this term and then that term. And this gives me what I have here. Now because the denominator is a binomial, I have to use a long division approach. I can't do a simple division. It has to be a long division. So the question is, what is your kill quotient? What is your remainder? And what's the divisor? You can never get the divisor wrong, as I always say, because it is always given in the problem. So I've answered the divisor for you. Go ahead and find the quotient and then that of the remainder, and then let's see what you have. When you are done, don't forget to test. Now your numerator is equal to the quotient you get times the divisor plus the remainder. Don't forget to test this. And that brings me to the end of my lecture video on polynomials. I hope that hasn't been a lengthy one. Take your time and take it again. Then the next video will be on rational functions as our 7th topic in algebra. Thank you.